Alright, so in this video I am going to show you how to make a simple model of a cart moving with the constant velocity in Glowscript. So the first thing we're going to want to do is we're going to want to go to glowscript.org. You're going to want to sign in or create an account if you haven't. In this case I'm signed in as the pcubed account. I can click here to go to my programs. Let's say I'll go to the private folder and I'll create a new program. Just call it video example. And I'll copy and paste some notes for myself so I don't forget anything. Here we can see that these are our comments. This just means that we put this little number sign here and these lines get totally ignored when we run the code. So we can see right now if I run this, absolutely nothing happens because all of these are getting ignored. First, let's maybe place down a road for our cart to go on as a nice visual guide. We can do that. We can literally just call it anything we want. So let's just call it road and it'll be a box. Then we're going to give this box some conditions. So what we're doing here is we're just telling VPython, you're going to make a box object and it's going to have the following properties. We're going to give it a position, so that's a vector quantity. Let's just put it at the origin. We're going to give it a size, another vector quantity. Let's make it long in x, and then 0 in the other direction. Maybe not 0, maybe 1 in the other direction. So if we run that, we can see, yeah, here it is. And you can right-click, pan around, take a look, use your scroll wheel to zoom in and out. And yeah, we've produced a nice bit of road here. Fantastic. Let's actually make the cart to go on the road now. We can make this be another box. Let's give this a position a little bit off to the left. Oh, forgot my equal sign. Position a little off to the left, maybe. So -400 maybe. And then we'll give it a size of, we'll just make it a cube. Side length 1. Oh, you can see I forgot to call size a vector. It's very important. If you put this without the VEC, the computer won't know it's a vector, and it will throw an error like this. So now that we've defined it as a vector, we can actually run it, and we can see, oh, I think it's over here, but it's overlapping a little bit. So let's make our road a little bit smaller. In the y direction, let's flatten it a little bit, and then maybe we can see our cart better. Okay, so it looks like I'm going to have to move the cart up a little bit. That's easy. We can just look at the position. Instead of this being 0, it's going to be 0.5. Let's also change the color of the cart so it's a little bit easier to see. We'll do that by saying color equals color dot. Let's go with red. And again, if we run the program, here we go. We're producing it just fine, although it is a little bit overlapping. So we'll make one final edit. We'll make this just a little bit smaller in the z direction so we don't get that overlap here anymore. Fantastic. Now we can actually add some parameters to our model to figure out exactly what kind of motion we're going to be modeling here. So let's give the cart a velocity. We can start by defining the velocity inside the cart itself. We can do velocity equals vec, so remember velocity is a vector quantity, and let's just define it to be 0. And of course, that doesn't seem very useful if we actually want our model to move, but what we can do is we can go in this parameters and initial conditions section, and we can do cart.velocity. And what is this going to do? It's going to say, look at the cart object that we're defining above, and then specifically look at its velocity, and then we're going to define that to be some new thing. We'll say that's vec500, so our cart will be moving to the right. And it's always nice to put our units. Let's put a little comment here, meters per second. Now, of course, even though we're giving it this new velocity, if we run the program, we still get the same thing we had a minute ago, where it just kind of sits there and nothing happens. That's because we don't have a loop to make the physics happen. We don't have any sense of what the time is here. So let's get our time set up. We can start with what's kind of traditional, is you start with at just time equals 0, so that's simple. We can define our time step. That's how much the computer will increase the time by each time there's a calculation. Nice value here might be 0.01, and we can always adjust that if we need to. Then let's define our final time, which we usually just call TF, and we'll say that's 2 seconds. Now we can actually start to create our loop, and our usual tool for doing that in this class will be what's called a while loop, and a while loop will just run a bunch of lines of code over and over and over again until some condition is met. So we're going to do while. We'll say t is less than tf, so run until we've reached the final time. We have put a little colon at the end, then you hit enter, and note that this is indented now, so everything that's indented at this level will be part of this while loop. So let's simply just say t equals itself plus dt. What is this going to do? It's going to update the time by taking the current time, which will be this t, and then adding the time step to it, which we've defined above. That's going to be constant. And now if we want to actually see this, what we can do is we can give this a rate that will basically say how many times should the computer run this loop in a second. And then we will do a print statement. That just means that the program will output what the current time is, and we'll just say print t, or maybe we'll do t equals t. What am I doing here? If you put words in quotations, it's called a string. And basically it's just like a word, and it will just output the word here. We put a comma and then t. So if we run the program, we can see, hey, look, the time is going up and up and up until we reach our final time. And it's going in steps that we would expect from our dt. Fantastic. So now we don't really need this anymore. In fact, I really don't need that, so I can just delete it. Usually you can just comment out lines of code in case you need them later. But in this case, I think that was simple enough where it's okay just to delete it. So now we can actually update the position of the cart. We're going to do that with cart.pos equals itself plus its velocity times our time step. So let's take a second to talk about where this equation is actually coming from. So it's an update equation because it has the form of something equals itself plus something else that you're updating it with, just the same way that we're updating our time. But the thing we're updating is position. We're updating it with this. And what is this? This is velocity times time. And if you remember our constant velocity equation, v equals d over t, you can arrange that to be velocity times time equals distance. So this is really just saying we have some little tiny distance for our time step. We're adding that to the current position to update where we are. Let's actually run this and see what happens. Hey, it moves to the right. Oh no, it keeps going a little bit too far. So I think there's a nice way to get around this. Instead of running until we have this final time, we can change our condition for the while loop. So let's do cart.pos.x, so specifically the x part of the cart's position. And we'll say, while that is less than, I don't know, let's go with 5. Maybe 4 would be better. And we can run the program again. It should stop right there. Perfect. Maybe we're interested in how long this took. We can use our little print trick again. We can put it after the while loop so it doesn't keep printing every time the loop runs. And then we can do prompt. Then we can do print. I really can't spell today. Print t. We can do t equals again t and run it. You can see this takes 1.61 seconds for it to travel this distance. Fantastic. Now, one important thing to note is that while in this video we made a program from scratch, in this class we're never going to ask you to make a program totally from scratch. We're always going to give you something that's already partially working, and you're only going to have to edit, a couple lines. But in this case, we just wanted to show you a full program from start to finish, just so you can see what all the different parts are in case you've never seen Glowscript before.